So in this video, we are going to try to draw the stress element or the cubes for the structure under the torque load. So what we are going to do, we're still going to do a cut at the plane you want to draw the stress element. And then you are going to base down the FBD to draw the stress cubes or the stress element. So now let's take a look. We need to draw the stress element at A and B. So we take a cut at the AB plane. And now you can choose the free end side or the fixed end side as your FBD. However, this time I would recommend you to use the fixed end side instead of the easy side as your FBD. Why? And I will explain later by drawing things, because this way your eye is going to see it a little bit better. So this is the FBD we pick on the fixed end side, and this is the location A and B. So now what we are going to do, we'd better set up the coordinate system. Normally the axial direction will be X, and then we say this is Y and Z. So now what we are going to do also needs to find out what is the internal torque at the AB plane. So we can see we had 800 going this way, and then the fixed end is going to have 500 Newton meter going that way. So which means the total internal force is going to be going this way, 300. So now what I like you to do is try your best. So we have to try to draw the stress element and the stress cube at the cutting plane, at the point you want to plot first. So this is the AB plane. Let's try to draw it in the 2D way and we back to the 3D. So you can see the internal torque is going to be 300 going this way. So I also want you to do one more thing, is try to shade the cutting area on the stress element, stress cube and element. So now what we can do is you can see the front face is going to be the cutting face, and this is the reason I recommend you to choose the hard part as the FBD, because your eyes can see this easily, okay? If we were picking the free end side as your FBD, then the back face is going to be the cutting plane, and that's the area you need to shade it. Okay, we already had this, and what we are going to do is curl your hand. You can see when we're passing through B, actually the shear stress direction will go up. However, when we're passing through A, it's not vertical anymore. It's actually go to the horizontal and to the left. So this is actually going to show us the real direction we are going to draw on the stress element. So for example, if we want to draw the stress cubes at A, first of all, the front face is the shaded area. And when we try to curl our hand, we already know at A it's actually go to the left. So which means after we find out this stress, we are going to use the head by head, tail by tail to finish the stress cube drawing. And then if you try to draw the stress element, which is a 2D situation, which means your eye have to take a look in this direction, and then you are going to see the X and Z plane, and on this plane, this bottom line here is actually your front face, and remember your stress have to go to the left. And then after this, you can do the head by head, tail by tail to finish the stress element drawing at A point. So now let's try to draw the stress element at B, the stress cubes. Again, try to shade the cutting face. And we already know at this cutting face, at B is actually go up, which is in the y direction, positive y direction. And then we can finish this by head, tail by tail. You can see on the same cutting plane, we act at different location, we actually had a different stress element. And then we are going to take our look from this direction. Our eye will go this direction, and then we are going to see a stress element here. And then we are going to see the XY plane. And then which line is going to be your cutting face is actually this line. So which means we are going to draw our shear stress in the positive y direction. And rest of them is going to be head by head, tail by tail.